So here we are with example 8. Find the range of each of the following functions. F of x is equal to 3x minus 2. Given the domain is the set of values. So these symbols here, curly brackets means the set. So the set of values where x equals 1, 2, 3 or 4. Or and 4 perhaps I should say. And we've got to remember that the domain is the inputs and the range are the outputs. That's what we're looking for. So, if you think of these as mappings, we've got 1, 2, 3 and 4 going in. The mapping is f of x is equal to 3x minus 2, or we could write that as f of x is such that x is mapped onto 3x minus 2. So that would be another way of writing the same thing. And we've got there then 1. If we put 1 in here, we get 3 times 1 is 3, take away 2 is 1. So 1 gets mapped onto 1. 2 would get mapped onto 3 times 2 is 6, minus 2 is 4. 3 gets mapped onto 3 times 3 is 9, minus 2 is 7. 4 gets mapped onto 12, minus 2 is 10. So we get 1, 4, 7 and 10. So how are we going to write that out? So the range then of f of x is the set 1, 4, 7, 10. So that is part A. We're also asked to state whether the functions are one-to-one or many-to-one. Well, we can clearly see here, I hope, that each input has its unique output. So that means it is the mapping will be 1 to 1. Part B. Now, the difference here is that when we look at the way the domain is defined here, that x is a member of the set of reals, x is a member, x is a member, that's the curly bit, or the E kind of bit, and the R bit is the set of reals. So in other words, all the values between minus 5 and 5, rational and irrational numbers. Okay, so there we can't, or we'd have to write out a lot of numbers if we were to use this kind of structure to our answer. So this is much better represented by a graph, a sketch. So we're going to sketch the graph. And we can see it's x squared, so that's a shape we're familiar with. But key that we understand that this graph starts at minus 5 and finishes at x equal 5. So there are x values, there g of x, and if we could write g of x, the graph is g of x is equal to x squared. So what do we see then? Well, what will be the upper limit on this graph? Well, the upper value, if we're squaring, is going to be 25. Yeah, you put negative 5 in, square it, you get plus 25. Put 5 in, you get 25. The lower limit, if we look down here, is 0. So our range of g of x is, and again we can't list out all the values, so we've got to do the same kind of idea. G of x is a member of the set of reals, and g of x is greater than or equal to 0 and less than or equal to 25. Curly brackets at the end, just squeezed in there. Sorry about running out of space. Okay. And finally, is it 1 to 1 or many to 1? Well, hopefully from what we've learned, we can see we've got two values going in to give one output. So that tells us the structure is many, because more than one input gives an output. So it's many to 1. Part C. 1 over x. Again, notice what's the domain? The domain is a set of real numbers, so it's lots of values. Yeah, lots of values. So we start with a sketch. Yeah, it's all the values between 0 and 3. So sketch graph. The graph this time is the reciprocal graph. Notice that we're going from 0 to 3. And this time we've got a strictly greater than sign. So 0 here is excluded. So there's x, there's y, or h of x. And the graph is h of x is equal to 1 over x. This goes up very, very high. When we go across to 3, our output value will be a third, 1 over 3. So when you put 3 in here, we get a third out. These are our inputs, remember, and our domain. And this is our output and range. So now again we've got to write it down using our function notation. So we want the range of h of x is, well, the first part, h of x. Have we got basically an infinite number of values, a continuous line? Yes. So it's going to be a member of set of reals. And h of x, what's the lowest value, is greater than a third or equal to, because we were allowed 3 in. Yes, if we look back up here, we were allowed to input 3. So that gives a third, and h of x is greater than or equal to it. And this time, again, it's 1 to 1. Because each input has an output, and we made sure in this question that 0 here was not included because of its 0 is less than x. Hopefully that's clear, and we'll move on to example 9.